Very good morning to everyone, and welcome to this energy simulation training program. Let me start my presentation by just explaining the difference between vehicles and building. When we buy a vehicle, generally we look out for mileage, and similarly, we need to also check when we try to buy a building. But the advantage of what we have when we buy a vehicle is you get an option to take a drive, test drive before you actually buy. And you can also check what is the mileage of that particular vehicle. But in case of buildings, we don't have such things like if you are planning to construct a building, the building may take time, maybe 2 to 3 years time to actually have that building and then get the first electrical bill. But suppose if you want to know before constructing the building itself, what will be the overall power consumption of my building? So for that, we need a tool, and there is an energy simulation tool where in a virtual environment, you are going to model the building with the realistic values like number of people, the type of wall, the orientation, location of the building, what type of facilities you're going to provide, the HVAC systems which you are going to select, how efficient the systems are, the lighting luminous which you are going to select. Because building comes in different shapes and types, and every building will have its own load, has its own power consumption. So the final thing which we need to check when you get any energy simulation report is EPI, Energy Performance Index. So this number gives the performance of that building. Suppose I tell you I'm having a motorcycle which is giving me 3 kilometers per liter. So your eyebrows will raise up. You may think, what dumb vehicle am I driving? Similarly, when you see this number, kilowatt hour per square feet, you should be able to understand and predict what will be the type of building, whether the building is efficient building or efforts have to be made to make it efficient. So the check figures which we need to know is annual energy consumption divided by the total carpet area. Generally, the range would be around 10 to 25 kilowatt hour per square feet. If it's coming above 25, that means your building is inefficient. You have to work hard. You have to try to add some insulation. You have to use some efficient techniques to make this number down. And then if it's below 10, that means there is some mistake in your simulation. Maybe you might have not considered all the parameters properly. So you can again have a look at it. So an efficient building will have lesser EPI, Energy Performance Index. Similarly, 1 ton AC, how much area it will be able to cool? So generally the range is 150 to 300 square feet per ton. So higher the better. So there are many buildings which has got more than 300 up to 800 square feet per ton also people were able to achieve by using efficient technologies. So with a simulation tool, we are trying to come out from this trend of having indoor units which are indoor and outdoor unit, the air conditioning systems which are not efficient. So we are trying to come out from this trend of 100 square feet per ton to 400 to 600 square feet per ton. There are various case studies, and one such as Rajiv Gandhi International Airport. It was able to save 14.58 crore of energy per annum because they went with efficient system. Now ECBC, Energy Conservation Building Code, for all commercial buildings have become mandate. So we are supposed to use ECBC compliant air conditioning systems, that is at least 3-star air conditions we have to use. So these are the units which we should be aware of: EER, COP, and kilowatt per ton. EER, it stands for energy efficiency ratio, and it's the output by input. output is in BTU per hour. This is the cooling capacity, and energy input is in watt. And then we have COP, coefficient of performance, which is again output by input, where output is in BTU per hour and energy input is again in BTU per hour. Then we have specific energy consumption, that is kilowatt per ton. So we got energy input in kilowatt by the cooling capacity. So EER and COP should be higher, the better, and kilowatt per ton should be as low as possible. Generally, for smaller air conditioners like split AC, we use EER as an unit, and for bigger air conditioners like chiller, we use COP as a unit to measure the efficiency. For example, you can see here we got different star rated air conditioners 1, 2, 3, 4, and 5. You will find ER of a 5-star AC is higher. That means the unit is efficient. So ER is the cooling capacity by the power input. For 1-star AC, it's around 2.43. So while selecting an air conditioner, we need to check the ER or COP and select the one which is better. Now we know that residential and commercial sectors consumes approximately 25 to 35% of the total electricity usage of the country. And in India, commercial buildings are a major source of high electricity consumption because of maybe lack of awareness, careless usage of electricity, old buildings which are not designed for air conditioning purpose. So now when we try to break up the energy consumption in buildings, we'll be able to find out that around 57% power is consumed by our air conditioners alone. And then we have 5% power that is being consumed by the ventilation fan. You may have basement car parking ventilation, kitchen ventilation, toilet exhaust system. So that may consume around 5%. So when you total up, generally for a building, it may be around 62%. So more than 60% power is consumed by HVAC system, which is a major and biggest guzzler of power consumption. And then lights may consume around 22%, and miscellaneous equipments, your computers, your peripherals may consume around 16%. So the biggest part is shared by the HVAC system. So when we select HVAC system, if you are having a ceiling fan, generally this fan, if you are keeping it in a closed room and if all doors and windows are closed, and if you keep a thermometer to measure the temperature before switching on the fan and then after switching on the fan, you will find the temperature will not change, but we feel comfortable. Reason being, the air which was hot and humid near our body was blushed and was flushed with dry and hot air. So the sweat evaporates and we feel comfortable. But this fan consumes around 9 watt per meter square of power, and per year that comes around 15 kilowatt hour per meter square. Then we have an air cooler. Air cooler would not be removing the latent load, it will remove only sensible heat. That means moisture will not be, it will not be able to remove it. So that's the reason in high humid areas we won't be able to utilize the effectiveness of air cooler. So room conditions would be 29 degrees centigrade. Yes, the sensible heat is reduced, but latent load will not be reduced. You can check the power consumption from 9 watt, it has increased to 39, because in air coolers we have got a small pump which lifts the water and wets the mesh. Outside hot and dry air, when it passes through the wet mesh, it becomes cool, and cool air you'll be supplying to the space. So the mesh will offer resistance to the flow of air. That's how the fan capacity will increase. The pump will again consume little power. So that may contribute to around 39 watt per meter square. And in year, it may come around 70 kilowatt hour per meter square. Now moving towards air conditioners. Yes, air conditioners can provide you sensible and latent both cooling. You can also reduce the latent load, but at what expense? You can see the per consumption of air conditioners is 194 watt per meter square, and per year this comes around 244. So when you compare with a non-air conditioned building, this is IIT Kanpur, wherein the temperature is comfortable, but yes, you have to adjust with the humidity, the latent load, and the cooling energy performance index is 22 kilowatt hour per meter square per year. And to generate this much power, the CO2 which is generated is around 28 kg per meter square per year. So we have trends in air conditioning designing for buildings. So the building which you are seeing here is an air conditioned building which has comfortable temperature, maybe 24 plus or minus 2 degree with 50% relative humidity. And then the power consumption will be around 102 and CO2 emission is 130. So from 29, it has increased to 130. If you check the trends in building design, this is a non-air conditioned building and this one is air conditioned building where you have both sensible and latent cooling. The power consumption is around 102. The building which you are seeing here is again an air conditioned building which has both sensible and latent cooling, but the power consumption is very high, around 260 kilowatt hour per meter square per year. So you can see the difference. Inside the building, the temperature which you are setting is exactly same, but because the systems were not efficient, the glazings were ordinary, the wall insulation was not provided. So that might be one of the reason for this higher power consumption. So we have to ensure that we avoid having inefficient buildings and make sure our buildings are efficient. And this can be achieved by using energy simulation tool. So before constructing the building upfront, you can decide what type of material, what type of wall, what type of glass, and what type of orientation we have to provide, how much overhang we need to provide to a building, so that we know what will be the EPI and how to reduce the EPI so that our building becomes efficient. So basic principles of HVAC systems and making energy efficient HVAC and making sure our air conditioners use low energy strategies. So with sustainable cooling, we don't advise the occupants that we will not be using an AC, but we provide them adequate thermal comfort with reduced energy demand and use renewable energy sources as much as possible. So we have seen till now that air conditioners consume huge amount of power, but let us see what makes the building consume more power. That is what makes the air conditioners consume more power, because air conditioners are designed to remove the heat from the space. So what are the contributors for heat gain? So you'll be able to see that 55% of the total heat gain is because of glass. And this is the thermal imaging image of a building which clearly depicts that this color shows window and you can see a high amount of heat. Ingress is through the windows. So try to get efficient glass so that we can reduce this heat ingress. And then internal gain because of light, people, computers. For tall buildings, you may have higher heat gain through wall, and for flat building, you may have higher heat gain from roof. So instead of ordinary glass, we may select efficient glass. Then making sure our buildings are oriented by reducing the heat ingress towards the eastern and western face. Try to maximize the glazing towards north side. So when we start doing the modeling, the things what are generally required is your architectural drawing, the structural drawing, and your RCP plan. The entire load of the building will be on the structural layout, because air conditioning duct can't break the beams and column, and you can't run that those fixtures and fittings. So you have to coordinate with the structure of the building. And we have different types and shapes of false ceilings, as you can see here. And here, this is a coordinated ceiling layout where we have air conditioning diffusers, lighting luminaires, and say your sprinkler system for fire. So all services should be coordinated with the ceiling layout. The type of false ceilings could be broadly divided into plain, step, and tiles false ceiling. Here you could see that we have three rooms. The first room has step false ceiling. There are two levels. This is the finished floor level, soffit of slab, and this is the place where all the facilities will be running, like your MEP services, HVAC system, plumbing system, electrical system, firefighting system. And then this is tiles type of false ceiling, which is generally recommended in kitchen area. If the tile becomes dirty, you may slide it up and remove it and clean it up. And this is plain false ceiling. So the heat ingress to the space will be through people, number of occupants you have in the space. And then heat ingress will be through the envelope, that is your wall, roof, glass. You also get heat through infiltration. Infiltration is the unwanted air which enters through our window cracks and door openings. Then we also get heat ingress through electrical equipments. There is also an impact of outdoor design conditions on our cooling load. So that's the reason we are supposed to select the right weather file. For Indian cities, we may get the details from ISHRE. And then we have to set proper indoor temperature, because if you set your thermostat to too cool position, again the overall power consumption will be higher. We have to ensure that spaces get proper fresh air as per ASHRAE 62.1 or NBC code. To make the space efficient, we can also install a CO2 sensor which can check the ppm level of carbon monoxide, carbon dioxide in the space. And if the differential is more, then the fresh air damper can open and fresh air can be supplied. So you can see here, there are two rooms. In the first room, space is crowded and you can see more fresh air is coming in, so that the differential between inside and outside is less than 530 ppm. When number of occupants are less, the fresh air damper is controlled, throttled, so that less amount of fresh air is taken in, so that load on your air conditioner would not be higher. The power consumption of your equipment and the minimum equipment efficiency is provided in Energy Conservation Building Code, as well as these values are given in ASHRAE 90.1 standard. So air conditioners could be of different types. The one which is commonly used is the window AC, as you can see here, where all components are packed in a box. You have got compressor, condenser, expansion device, evaporator coil, everything is packed in this box. To install a window AC, we need an exposed wall, and in split AC, we have indoor unit that can be placed inside the space, and outdoor unit can be placed in well ventilated place outside the building. You may keep it on the roof or behind the wall. There are different types of indoor units. Either you may have ceiling wall, cassette type, ceiling, ducted split, or floor stand AC. So these type of air conditioners are generally referred to as DX, direct expansion, or unitary system. And now moving towards the central air conditioning system, we have got chillers, air cooled and water cooled chillers. We have cooling towers. We may have air handling unit. To start with, in non-central air conditioning system, we have window air conditioners and split air conditioners. So this is what happens in any DX system. DX, which stands for direct expansion, we have a compressor which compresses the refrigerant. We get high pressure, high temperature refrigerant, which passes through the condenser coil. And there is a fan, and this is the condenser coil where heat is removed. And we get low pressure, low temperature refrigerant, which passes through the expansion device. And then finally it comes through your evaporator coil. And this evaporator coil will have chilled refrigerant. And when fan blows over this chilled refrigerant coil, the air becomes cool. So this is a cutout view of a window AC. So you can see room air passes through the filter, gets filtered, touches the coil, becomes cool, and cool air you are supplying to the space. You have to install window AC in such a way that the condenser coil faces the ambient outside temperature. So the heat can be removed from the condenser. And you might have also observed window ACs create a lot of noise because it has a compressor. And the challenge will be you need to have an exposed wall. For interior rooms, this becomes little difficult to install a window AC. And window AC comes in smaller capacities. So what can be done is we can split the cycle into two. We can call this unit as an indoor unit, evaporator coil and blower, and compressor, condenser, expansion device, we can consider it as an outdoor unit. So this is a split air conditioner where we have indoor unit which has evaporator coil and blower, and outdoor unit which has compressor, condenser, expansion valve, and axial fan. So this is the indoor unit, and then we have an outdoor unit. So indoor units could be of different shapes. The one which you are seeing here is a wall mounted split AC. When you lift the panel, you will find filter so that air can be filtered. Room air passes through the filter, gets filtered, touches the coil, becomes cool, and cool air will be supplied with the help of blower to the space. And this is how the space would look once you do the installation. We may have different style of indoor units like floor or ceiling mounted air conditioner. Either you may mount it on floor or put it on ceiling, or you may have floor stand AC. This can be used for atriums, library, or spaces with high ceiling height. And then we have cassette type air conditioner which can be installed in your false ceiling in the center of room. Because the air conditioner is installed in the center of room, you need to have a condensate removal pump that can remove the water from the evaporator coil and send it to the nearest drain line. So we have to lift the water against the gravity. So for this reason, we need to have a condensate removal pump. This is how a typical cassette type AC will be installed. And in case the small pump, the condensate removal pump, if it fails down, then water starts dripping from the ceiling. So people are a little scared to use this AC because of the problem of condensation. So that we have seen different types of indoor units, and now coming towards outdoor unit. So these outdoor units either can be mounted on the roof like this, but once you mount it on roof, you won't be able to use this space for any other purpose. So if you have a roof and if you are putting your outdoor units here, you can't use it. So people prefer installing it on the backside of wall. But again, it may spoil the look of your building. So that's where here you could see that every indoor unit was having an outdoor unit. And that's the reason you can see so many outdoor units have come up. So this problem can be overcome when we use VRF system, variable refrigerant flow or variable refrigerant volume is a system wherein we have one outdoor unit with multiple indoor units. So you don't have the problem of having so many outdoor units. Again, this is a DX system. So multiple indoor units can be connected to outdoor unit. It provides superior design flexibility, conserve spaces, and then conserve energy with modular switching. Then we have ducted split AC. It's also known as hideaway unit because it will be concealed above the false ceiling. You may have high capacity of duct type air conditioners. This AC will be concealed in the ceiling. So as you can see here, we have an air conditioner which is above the false ceiling, and this is the duct through which cool air will be supplied to the space. So in central air conditioning system, you may have a duct that may supply cool air, one towards the left hand side and the other one towards the right hand side. So this is the supply linear bar grill through which cool air is being supplied to the space. The air becomes hot and dry, uh, hot and humid, and this because we human beings generate latent load, so the air becomes hot and humid, and it will return back to the unit. On the other side, we have got a duct, flexible duct. We have got a diffuser box, and then we have a diffuser through which cool air is being supplied, and air returns back. So as per Energy Conservation Building Code, the duct which you have seen should be insulated. The above space, this cavity acts like a return space or return path for the duct. And the air passes through the filter where it gets filtered, and filtered air passes through the coil. And here you can see we have got chilled water supply and chilled water return pipe. There is a pipe to remove the condensate drain, and you can see there is a U shape here so that it can act like a U trap, which will not allow the bad odor from your drainage system to get supplied to your air conditioner. That's the reason we have this U trap. So the condensed water will try to restrict the flow of this bad odor, will act like an airlock. So in our ducted split AC or fan coil unit, we have got a filter, we have coil, and then a blower. So air passes through the filter, gets filtered, passes through the coil, becomes cool, and cool air you're going to supply to the space. So when we select a blower, the capacity of the blower will be based on the flow rate, the quantity of air that is being supplied, and the ESP, that is external static pressure. Lengthier the duct, more the bends are, higher the static pressure would be. And in this slide, you can see that we have these symbols, plus and minus. So the symbol plus indicates we are supplying more fresh air, more air than we take return. So supply is more than return. So that's the reason you can see positive pressure is there. So you could see that air is leaking out and exfiltration is happening. Exfiltration. So outside dust, mosquitoes, insects will not be able to come in because we are maintaining positive pressure. So all clean areas will be having positive pressure, whereas where you have smoke, so all dirty places like car parking area, toilets or kitchen where you have smoke should be maintained under negative pressure. So here you can see that this kitchen is having a canopy hood is there, which creates a suction and creates a negative pressure. Now this is a clip taken from thermal imaging camera where you can see with naked eye, when you see, you will find a supply linear bar grill. But when you take an image, you'll be able to identify that these are the only spots from where we are getting cool air supply. And the other grill was only dummy grill. And here also you could directly see which one is the supply grill. And you may identify the problem also. In case an air conditioner is not working, instead of opening the panel and then checking, simply by taking a snap, you'll be able to identify that yes, there is some problem in the supply side. Maybe the coil is choked, it has become dirty, so cleaning need to be done. These are air terminals through which cool air will be supplied to the space, and we need to check and ensure that the space gets proper airflow. So there are different instruments to measure the airflow. We got anemometer to check the flow of air. To increase the efficiency of air side system, instead of having a constant speed fan, we can recommend to have two-speed fan. We may have variable speed drive on the air handling unit fan, like your ceiling fan. It has a regulator, it has 5 speeds. Similarly, when you are having a three-phase fan for air handling unit, which has a bigger capacity, so to control the fan speed, to modulate the fan speed, we need to have a variable speed drive. Then we have economizer, air side economizer. The function of economizer is to make sure the room air return side is ventilated out and you get outside fresh air, 100% outside fresh air. If outside air is cooler, and generally this happens only in the evening hours, so that outside fresh air 100% can be supplied to the space and room air can be ventilated out. Then we may also install this heat recovery unit, and then demand control ventilation where you can put a CO2 sensor. The terms what you are seeing here, like economizer, heat recovery, demand control ventilation. So once we use our eQuest energy simulation software, so there you will find these terms, and if you want to apply energy conservation measure, you can use either economizer or heat recovery wheel or demand control ventilation. So that's the reason we are trying to have a briefing before opening the software tool. So economizer provides a free cooling source when available. If outside temperature is cool, then you may give maximum fresh air. And when outside temperature is harsh, then you may provide minimum outdoor air. So as you can see here, this is the space. If outside air economizer is not used, you are supplying cool air and you are taking only the recommended fresh air. But If you are using economizer, if the return air temperature, if more occupants are there and if return air temperature is higher, then you can close this economizer valve damper and you can take 100% outside air. So outside air temperature may be around 76 or 78, maybe 76 or 74, whereas return air temperature may be around 78 or 80 degree Fahrenheit. So if outside air is cooler, so we can take advantage of it. And this generally happens in evening hours, and load on your coil will be less. And here you can see we have got a supply fan which supplies cool air to the space. The system is constant air volume system. So as the name suggests, the airflow is constant. So your fan will always be running at one speed. And if people are shivering, if they are not feeling comfortable, they can adjust the thermostat. And there is a heating coil which will warm the air and generate the temperature as per the desired set temperature in the space. So the disadvantage of constant air volume system is you are first cooling the air and then warming it up to meet the comfort conditions. Whereas in variable air volume system, you have got a damper which is connected with your thermostat, which will not allow more amount of cool air to enter the space. So damper will throttle. So instead of 100 CFM air to be supplied to a space, so if you are feeling cool, you may adjust the damper, you may set the thermostat setting. So the dampers will throttle, maybe only 80% air will be supplied. So there will be a back pressure. So the back pressure sensor will check and the barometric pressure gauge will give a signal to the fan to run slowly, and which in turn gives a signal to the return fan. So this system, when you are using variable air volume system, is an efficient system. You can run the fan at low speed. So you have to be aware of these terms like VAV and CAV, because when we use our energy simulation tool like eQuest, there will be we have to select the type of air conditioning system, because these are the systems which will have an effect on the total energy consumption of the building. If you if you are adopting the energy conservation measures, then you may select variable air volume system. We have seen air side economizer. Having air side economizer is not an option for any commercial building in India. So air side economizer is a mandate requirement as per the ECBC norms. And here you can see, once you are using outside air economizer, the damper can throttle, it can control the supply and return of air. And then we have demand controlled ventilation. So in demand control ventilation, we are providing a CO2 sensor in the space, which will check the CO2 level, and accordingly it will adjust the fresh air in the space. Then we have heat recovery ventilator. Basically, this is a heat recovery wheel. When you are throwing out room air, when you are relieving the air to ambient, the temperature may be around 76, and on a hot summer day, the temperature of outside air may be 106. So this 106 degree Fahrenheit temperature, when it touches a cool wheel which is cooled by the exhaust air, the air temperature will drop down from 106. Depending on the efficiency of your heat recovery ventilator, 80, 85% or 75%, the temperature will drop down. So load on your coil will reduce. So having this heat recovery wheel is again an ECM, energy conservation measure. So room air is thrown out via this heat recovery wheel which has an heat exchanger. So the wheel becomes cool. Outside air which is hot, when it touches the cool wheel, the air becomes cool, and cool air you can supply. So these are also known as enthalpy wheel. The advantages are it reduces the cooling or heating loads, and it downsizes the equipment, ductwork, and large ventilation. And the disadvantages are the initial investment, the first cost, because anyhow running costs will be less. And when air passes through the heat recovery wheel, the fan has to overcome the additional pressure losses. So the fan energy may increase, and you may require air filtration. And this is how the heat recovery wheel would look. So as you can see here, the wheel continuously rotates. Room air is made to pass through the heat recovery wheel, and then the air will be thrown out. And outside air is taken in, which touches the wheel and becomes cool. So we have only one wheel, and return air which comes in from the space. Suppose you have an hospital, the air may contain germs, bacteria, and which may cling to this wheel. And when outside air passes through the heat recovery wheel again, the air may carry those pathogens to the space. To avoid it, we may also have this style of heat recovery system. We can call it as glycol run around system or heat pipe or heat wheel. So wherein we have two separate heat exchangers, and we have a coil here and a small pump which is made to circulate the liquid. So you can see exhaust air, room air is made to pass through one coil, and outside air which is hot is made to pass through the other coil. And the refrigerant, which is say glycol, when you add to water, it reduces the freezing point of water. So that would be the refrigerant which will be circulating in this pipe. So the system is efficient. You may have around 60% efficiency. So instead of constant speed, we may have variable speed drives. So till now we have covered window AC, split AC, and we have also seen how a ductable split AC would look. Now the third type of air conditioner is package AC. Now package air conditioner have all the components what a typical window AC would have. It has a compressor, condenser, expansion device, and an evaporator coil, all packed in a box. So the name package implies that it has all components which are packed in a box. So as you can see here, this is the unit which is kept in well ventilated place outside the building. So return air mixes with the fresh air and passes through the coil. Air becomes cool, and cool air will be supplied with the help of duct to the space. As per ECBC code, Energy Conservation Building Code, the ducts should be insulated. You may keep the unit outside the building as it's shown here. This unit can serve either a big hall or can serve more than one room. Duct will be there through which cool air will be supplied. You may install the unit on the roof. The advantage of this unit is, if at all there is any maintenance requirement, the technician will come, he will do the repair from outside and then he will move out. Whereas if you have installed any other split air conditioner, then outsiders may intrude your privacy. They may come to your bedroom, they may open the ceiling. You might have a big mess when every 20 days or 1 month when filters are clean. So you have to give that space. So with package AC, you don't have that problem. All the maintenance will be done from outside. This is how a typical package AC would look. The unit can be kept outside with a supply duct, giving cool air supply to different spaces. And then we have return air ducting. Your package air conditioner can be air cooled or it can be water cooled. That is, the condenser can be cooled by air. As you can see here, the unit is outside and is cooled by air, or it can be cooled by water. So this is a package AC where we have a condenser coil. There is a pump which takes the water, gets the water from the cooling tower. Cooling tower is placed in a well ventilated place outside the building, and the cool water cools the condenser coil, and the hot water is sprinkled in the cooling tower. For forced draft system, we have got a fan which creates a negative pressure, which draws outside air and cools down this water. So this is water cooled package AC. And this air conditioner supplies cool air to the space, and you are taking return air back to the unit. So this is how a typical cooling tower would look. And this is your package air conditioner which gives cool air supply to the space. Now when we install the air conditioner, care should be taken to avoid the vibration transfer down to the floor. So we need to provide here spring isolators or neoprene pad. Ducts will be connected, and ducts need to have acoustic lining inside so that sound should not transfer down to the space, and sound can be restricted and can be avoided by putting acoustic lining or silencer. We need to also put flexible connection which is made up of rubber, because duct is made up of rigid sheet metal, and the package AC has got a blower, and vibrations may occur in the unit, and you don't want those vibrations to transfer down to the ducting. That's the reason flexible connectors are used. As you can see here, these are the package ACs which are installed, and these are the ducts which carry cool air to the space and then return air from the space. The ducts are exposed to weather. That's the reason they are having additional acoustic lining, weatherproofing. So here we have got cotton cladding with Foster. So this cotton cladding with Foster will not allow birds and insects to scratch down the outside insulation, and the insulation will have longer life. So there are two options. Either you can keep the package AC on floor like this, but the disadvantage is next 15 to 20 years till the life of the system, you won't be able to utilize the space. So you can keep these units on the roof like this, and then you can give the supply. You may do cotton cladding with Foster, or you may provide aluminum cladding over the GI sheet. So these are two options which are available for providing cladding or the insulation. Aluminum cladding has got good life, and we need to have 0.6 mm thick aluminum jacketing over the insulation. As per energy conservation building code, we are supposed to have good insulation for the ducts which are exposed to weatherproof or to weather conditions. So weatherproof jetting should be taken. Aluminium doesn't corrode, so we generally use aluminum sheets, but they are a little expensive. So few contractors, they prefer cotton cladding. So even on a raised stand, the unit can be placed. So now we'll move towards chilled water system. Chilled water system consists of chillers, air handling unit, fan coil unit to distribute cool air. So as you can see here, this is the chiller which provides chilled water. It's water which is circulating in the pipe. There is no refrigerant. If at all there is any leak, water will be leaking. Whereas in split air conditioners or variable air volume system, if there is a leak in the pipe, refrigerant will leak. But here you can see water is circulating. So cool water, the temperature may be around 45 degree Fahrenheit, passes through the air handling unit, and the return line carries 55 degree Fahrenheit water, which goes down to the chiller. Chiller is a device which will generate chilled water, and again the chilled water will be circulated to the unit and will return back. There is a duct which supplies cool air to the space, and we have a return air duct which takes return air from the space. You will identify here 2 points. One is we are taking outside fresh air, ambient air, because we don't want recirculated air to be in the space, because we inhale oxygen, we exhale carbon dioxide. So that's the reason fresh air need to be added. And to maintain neutral pressure, we have to exit out this air. And similarly here also you can see we are adding fresh air to the space, and then we are trying to relieve the additional pressure to the ambient. Smaller units are known as fan coil unit, and the larger units are known as air handling unit. So air handling unit has filters, has coil, and needs a bigger space for installing. A unit which has more than 5 ton capacity or which can handle more than 2000 CFM is known as air handling unit. These are smaller air conditioners which are less than 5 ton or less than 2000 CFM fan coil units. And here we have a chiller. So with this, now we have around 20 minutes time before we break for lunch. So I will stop the presentation file here, and then we'll continue from that slide onwards after the break. Now let me just open the Equus software so that you can have a look at it. So for those who are new to energy simulation, just trying to give them a feel of how the tool would look. This is your Equus software, and I have created a very simple model, and this model has 3 floors from the ground. This is first floor, second floor, and third floor, or you may call it as ground floor, first floor, or second floor. Then I have provided here windows and doors are there in the ground floor. When you click the simulation building performance icon, you'll be able to find the EPI of this building. Because the model is very simple, it took hardly a couple of seconds to give you the result. And you will find here there are 12 lines, bars, which shows the power consumption of different months like January to December. January to December. For space cooling, heat rejection, refrigeration, space heating, horsepower supply, hot water, ventilation fan. What is the total power consumption in the month of January? And you can see till December. And we have the total API. So this is one such report what we get as an output. The second thing what we get from the simulation tool is what will be your air conditioner capacity. For this, you may click your air side HVAC tab and then click on summary. Well, again, I'm just showing you trailer of the software. So we'll be working in detail. So when you click on summary, you'll be able to find out the tonnage of the space. For example, this building consumes around 281 ton. So now let us start with a new, I'm not saving this file. So let me start with a new project. So when you double click the eQuest icon, you're going to get this information. Try to install 0.64. I think the software is already shared with you. You may install it. And this is the first screen what you will get. If you want to open an existing project, you can select this tab. Or if you want to open a new project, if you want to create a new project via Wizard, you can select. So you can select, you can check, create a new project via Wizard. And once you select it, you can click OK. So we have here around 50 plus participants. Just wanted to know how many of you are parallelly opening this tool and trying to use with me, or you can give in chat, you can
I'll be
mention.
giving the files to them now. During break, they will install, and after break, they will start using it.
Fine, very good. That's fine. So after break or during lunch break, you may install it, and then uh, you may select this tab, create a new project via Wizard, and then click OK. Then we have two options. The first option is schematic design wizard. So today we'll be working on schematic design wizard. And this is used for the earliest design phase with basic information or simple schedules with simple assignments for internal loads and HVAC. So we will start with schematic design wizard. So you have to click on this tab, schematic design wizard. Later on, tomorrow we'll be working with design development wizard. Use this for later more detailed design when more detailed information is available for larger, more complicated structures, for more detailed internal loads, schedules, and HVAC system assignments. So we can click on schematic design wizard. And this is the first screen what you will see. And in the screen you can find here, there are 41, one of 41 sheets would be there. But you don't have all the sheets. Depending on the choice what you select, those many sheets will be visible to you. So if you count now, we have 1 of 41, we don't have 2, Then we have 3, 4, 5, 6, 7, 8, 9. We don't have 11, 12, 13. So based on the options what you select, those sheets will get highlighted. And you can see we have text color in red and green. So the moment you make any changes, for example, you can give any name to the project, and then building type, say it's office building 2-story. If I select any other name or any other building type, say if I'm selecting a mid-rise building, now you could see that the color has changed to red. Default values are in green color, and the moment you make any change, the color would change to red. Now, local location set. So by default, you can see the location is California. If you want to change the location, you can click this drop down. You will get a drop down list when you click this arrow, and we have options. You may select user selected. In weather file tab, now it's showing blank. You have to click these three dots. So the moment you click, you will get again a new folder which has different weather files of different cities. But when you install your software, this folder TMY2 will have hardly 2 sheets. So I have already shared with you weather files of major cities of India. So what can be done is, from your C drive or D drive, you may copy the files and you can paste it in this folder at this location. The extension of the file is .bin. You have to remember this path: users, public documents, equest, weather, and then TMY2. So in this folder, you may paste the weather files. If any new city or new weather file, if you want to download, you can go to NREL website and you may select the space and you may download, or you can get the files from ISHRE weather data file also. ISHRE, they have provided weather data details for almost all cities in India. So you can get those details also from there. And I have provided a few weather files and the extension is .bin. So as of now, let me start by selecting one city, say Hyderabad, and then I'm clicking open. Then you may mention here the building area. So you can select the building area and you may select floors above grade. That is how many floors you are having based on the ground level, that is grade. So if you are having 3-story building, you may select 3. If you are having basement floors, 1 or 2 basement, you may select 1 basement or 2 basement. Number of floors below the ground level, so you may select that. Now coming towards cooling and heating, you have an option here whether you have chilled water coils or DX coil. DX, direct expansion system. Say you have a split AC, you may use DX system. If you have evaporative coolers, you may select evaporative coolers also for passive cooling. Or if you have chillers, then you may select chill water coil. So for this project, we'll select DX coil. And I think I have already shared with you one document file. So if you find difficulty in pasting the weather file, you may use this document. So after installing the software, you may copy the .bin format weather files to this folder tmy2. This is the folder tmy2 where you have to paste it up. Then you have two options. Either you can start with schematic design wizard, or you can go with design development wizard. Now this point is very important. From basic mode, you can go to advanced mode. But from advanced mode, you will not be able to go to basic mode. So you have to take care. From schematic design wizard, you can always go to design development wizard, but not on the other way. So once we use the software, I'll be able to help you out with this. I will explain you how it is done. We also have energy efficiency measure wizard, which we shall be seeing tomorrow. So these are the steps which we have seen just now, like double click on eQuest, create a new project via wizard, select schematic design wizard, and then you can select an office building mid-rise. You can have a floor plate of 130 feet by 130 feet. Height of each floor, you can consider it as 13 feet. So these are the details of project what we are having. So we have 130 feet by 130 feet floor plate of a ground floor of a building. And say if you are having 3 floors, it will be 50,700 square feet. So same number I'll be mentioning here. Cooling equipment, I'm using DX coil, and heating equipment, I'm not using any heating equipment now. So building size is 130 feet by 130 feet, 3-story building. Total condition area is 50,700 square feet. So this was the first screen, an introduction to your eQuest tool. So So during lunch break, try to install the software, paste down the weather files, and try to open the first screen. Building area, you can mention 50,700, and above grade, you can mention 3. Cooling equipment, you can select as DX, and heating equipment, you may select no heating. So with this, we'll break now for lunch, and I hope it's okay, right?
Yes, sir. We can break for lunch. Since most of the attendees are with architecture background, so we thought it will be good to have an introduction to HVAC, how HVAC works, because that is where we find the challenge when doing energy simulation, especially. So I think what sir has given as a background was a good start. So I have pasted the link in the chat box as well as in your WhatsApp message. Okay, please download all the files required and please install eQuest during the lunch break, and after lunch break we'll continue with the class. So thank you, sir. We'll meet after lunch break again, sir. Thank you.
Thank you. Thank you very much.